Okay, last part of the study guide. We want to make sure we know how to draw the graphs for electrostatic force versus charge and force versus distance. So I'm just going to draw two graph setups here. I'm going to have force versus charge, and I'm going to have force versus distance. And I'm going to remind myself this is the electrostatic force, so we've got a constant times two charges, two charge amounts, divided by the distance between them squared. Okay. Oh, 1 second. Sorry. It takes some time, I guess. I don't know. Okay. Okay. So with force and charge, it's a direct relationship. If charge goes up, force goes up. Like if one of these goes up, then this force value is going to go up. So that's just a nice straight linear relationship. I can see as I go higher up on the charge axis, my force values are also getting larger. Okay. Distance is an inverse squared. We're dividing by distance and we're dividing by the square of distance. And so that graph looks like this steep, almost kind of weird curve, okay, where force is really dropping off as distance gets larger. And that's, again, because of this inverse square relationship here, okay? So just make sure that you can identify these two graphs. All right, and then the last two questions are about potential or potential energy, which was like the last thing we talked about for this unit. So we said that if a charge is near like charges, it's going to have the highest potential or potential energy because it wants to get away from those charges. It's going to repel from those charges. Okay. It has lower potential when it's near charges that it's attracted to, because it's going to want to go to those charges. It doesn't want to go away from them. It's going to have more movement when it's near a like charge because it wants to get away from it. So we've got two charged plates here. Okay, one is positive, one is negative. We've got a small positive charge that we're going to stick in the middle of these. We want to know at what point would it have the greatest potential. Okay, it's a positive charge, so it's going to have the greatest potential next to the positive plate because it's going to want to get away from that one the most. If we put it in the middle, it could kind of go both ways. If we put it down here, it's going to want to go towards this plate, but that's not a very long distance. Okay, its biggest movement is going to be when it's close to the side that it's going to repel from. And that's maybe seems a little counterintuitive, but that's the way potential works. And that's what we talked about the other day with how the battery works. Okay. And then one more. This is from the simulation that I showed y'all. So we've got two negative charges here. We've got a bar graph of their potential energy. And if we bring these two charges closer, is my graph going to move higher or lower, and why? So I already said I'm going to have higher potential if I'm near a like charge. If I try and bring these two closer together, they're going to repel each other. They don't like each other. They don't want to be near each other. So my bar is going to get higher. Okay, that's going to get higher because the two charges will repel with a stronger force. That's going to give them more potential because they're going to want to get away from each other more. Okay. And remember, repelling, just like attracting, is a force. I mean, those are both examples of the electrostatic force. Okay, so that is the study guide.